I want to point something out to you. Let me hit F11 on our current program and Control-Alt-D. And notice we have this call to do it, which we've seen before. Now you understand what the call instruction does. Pushes the return address onto the stack and also changes the instruction pointer. That's all it does. We're calling out to do it, which is at this address. But there's something about this that bugs me, and I hope it bugs you as well. I'm going to open the Windows snipping tool and just grab a screenshot of this real quick and scroll that up. Bring this up like that. Put it off to the side for a minute. All right, back to our program. I'm going to hit F11. And I'm going to F11 twice down to our next call instruction. And I want you to compare this call instruction that we're at right here with the call instruction we saw before right here. Okay, what's the difference between these two? Do you see anything that's different? Is there anything in there that kind of bugs you or rubs you wrong, or rubs me wrong? And that's the purpose of talk about in this video. Pause the video, think about it if you need to. You can see here that when we do this call here, we call do it by name. In fact, the name DOIT still exists in our disassembled code. However, when we make this call here, do you remember our call right there is to, let me go back to our original assembly. We made this calculate next power function right there. Calculate next power. We're calling out to calculate next power. But if I bring back the debugging code like so and go over here, do you see calculate next power anywhere in here? Yeah, I don't see calculate next power anywhere in here. I see do it plus 2D hex, which is an offset. Basically start at the address that do it indicates, go forward in memory 2D hexadecimal bytes, and right there call to that location. So what happened to the name calculate next power? Do you have any idea? Probably didn't care, but do you have any idea? It's actually quite critical to understand. Let me erase all that off, and I think well, I'll just set this aside just in case we need it again. Let me bring back our assembly code, and I'm going to scroll this up. I'm going to grab right here and drag this down, and then bring calculate next power right here, and then let's find do it. Do it is right here. Do you see any syntactical differences between do it and calculate next power? Hopefully it sticks out and it's obvious. Calculate next power is followed by a colon, whereas do it has no colon. Instead, it is followed by PROC, or proc, which is short for procedure. Now, what's the difference? Well, the main difference is labels are only known to the assembler, whereas procedures are externally linkable. Oh boy, I just said two words there, externally linkable, and that might have just burned your brain cells up. Let me see if I can explain what's going on here. First of all, calculate next power, the only way we can call it is within our assembly program. Alright, I can say call calculate next power, that pushes the return address on the stack, and then also change the instruction pointer down here. But it's only visible, let me get rid of that, it's only visible within the assembly program. However, do it is visible outside of our assembly program. Do you remember in, I think it was the second video in this playlist, I had to jimmy rig Visual Studio to do what we're trying to do. I had to say, hey, I know assembly is not native to you, Visual Studio. I know Microsoft didn't build you specifically to do assembly language. You're good at C++, you're good at C# and other things like that, but you're not built specifically for assembly language. So I had to jimmy rig Visual Studio to do this assembly language stuff for us. And the way I did that was making a simple C++ program with a main procedure. This is where execution starts. And I just said, hey, call do it. And by the way, do you see a do it anywhere in this file? Well, we see the name do it right here, but we don't have any implementation for do it. I'm saying it is extern, meaning external to this CPP file, this C++ file. It's external, it's using C formatting, don't worry about that. And it's do it, if you don't understand the void, don't worry about that either. Okay, I'm just saying, hey, there's a do it out there somewhere, and that'll be resolved later. In the meantime, call it. So the C++ compiler walks by faith and says, okay, I'll just whatever you say it's there, so I'll just call it. And what the C++ compiler outputs when we run the C++ file, when we run the C++ compiler on this file, here's our file. All right, I'm drawing our file. Here's our C++ code. Here's main. That's a main. And here's doit. We're calling doit in there, and there's some curlies and stuff. The C++ compiler takes this file, and the C++ compiler is called cl.exe. It's short for compile and link. Anyway, it takes it, and it spits out a .obj file, short for object file. Not something we can execute directly. It's a temporary stopping point from C++ land to our target goal, which is an executable file, or a .exe file. That's our end goal. So the C++ compiler stops there and says, here's an OBJ file, sure, whatever. And in the meantime, on this other file, our assembly program, do you remember one of the first things we did early in this playlist is, let me get rid of all that. We right-clicked on this and went to Properties, get that off the screen. Custom Build Tools, General, and we had to set all this up. This is my Jimmy rigging of the Visual Studio to get it to do, to assemble this file for us. And we run it through the Microsoft Assembler, ml.exe, and we gave it these arguments. Don't worry about what they mean. But then it also outputs a .obj file as well. Okay, and the name of that file will be the name of the input file name, which is my assembly. So it'll be myassembly.obj. Let me see if I can get that back up. So here is our assembly code. Lots of assembly, our static data, all this stuff in here. Bigger circle, there you go. Is all right here. And let me just erase that, it's going to bug me. All of our assembly code's there. The Microsoft assembler, ml.exe, goes to working on this file and also produces an OBJ output as the result. So we have two OBJ files. One has doit inside of it, and one has a call to do it. And the way we denote calling a procedure in C++, we put the parentheses on the end. Go watch my C++ playlist if you want to learn more about that. Anyway, so now there's this dilemma. We have two OBJ files. This one is referring to the other one, but it doesn't realize it. Okay, it's just saying, I'm calling doit, I'm walking by faith. I don't know where it's at. I'm just going to trust something will patch it up later. And the thing that patches it up is something we call the linker. So let me just go to blue here. And the linker takes both of these OBJ files, and it notices the call out to do it here and says, oh, I know where the address of that is. I'll take both of these as inputs and patch up that call to do it. So now we have the call to do it inside of our exe, and we also have the doit code inside the exe that came from this OBJ file. So the call is coming from there, this code's coming from there. The linker puts them both together and stuffs them into one executable and resolves this call so that when we do the call, it goes down there. So when I say that doit is externally visible or externally linkable, that's what I mean, is the name doit must be preserved by the assembler so that any other assembly and or C programs producing OBJ files that reference it, they need to be able to see that. So the Microsoft assembler preserves the name DOIT so that the linker can patch that name up later. Now it just so happens that part of preserving the name and part of calling the name is prepending the name with an underscore. That is C convention. C++ does something called mangling. Don't worry about that. But basically they throw the underscore out here, and that is the reason why we have the C here. Okay, I'm saying, hey, when you call doit, we're calling it C style, not C++ style. All right, hopefully that doesn't hurt too much. But the that's the reason why the name doit is preserved. When I hit F11 here and Control-Alt-D, we can see underscore doit, the DOIT is preserved. Then I can hit F11 and so on and so forth. However, the calculate next power procedure is not externally linkable. In fact, it's simply a label. All right, it's low on the totem pole here. It just says, hey, here's the address of this instruction. It's a colon. It's only visible to the Microsoft assembler. It's not visible outside. Now, I could certainly make it visible outside and then call it from C++ the same way that we're calling doit. However, there's a stronger, more compelling reason to turn this into procedure instead of just a simple label. Let me try to zoom out here. Turn your quality up to high definition again. But let's look at doit here. All right, doit starts here. It goes down here, and really all doit is, we should probably name it something else, but it's just running that algorithm where it's 2 to the 0 plus 2 to the 1 times, or no, is there a plus? Sorry, there's a times here and there's a plus there. It's running that algorithm that we've been working on over the last several videos. And so I should probably name it like calculate my algorithm or calculate powers, multiplication, addition, something a little more straightforward. But then doit, the scope of doit or the range of doit, the length of doit goes all the way down to doit's DOIT end procedure directive there. Let me scroll in here just so you can see it. Doit end proc. All right, so doit runs. Oh boy, that's too small. I can barely see it myself. I hope you can still see it. Doit's scope is from here to here, whereas this calculate power next power logic, its scope is from here to here. And so all of a sudden I have this embedded function or embedded procedure or embedded scope, or it's inside of this larger scope. And there's cases where that makes sense. I mean, right here we're really only using calculate power inside this procedure, so maybe it makes sense to embed this code directly inside of this doit procedure. However, probably a better way, maybe, and this is totally a religious debate, is to instead make calculate power its own procedure. So let me grab this here and paste this here and save this. And let me just prove to you that I can leave this out here. Control-Shift-B. Yes, stop debugging. Build succeeded. The code will still function the same. But I could also say, hey, this calculate next power, it is a procedure. I can end that procedure right here by saying calculate next power end P, the exact same as we did with doit. All right, now calculate power, since it is a procedure, is externally visible to the OBJ file that will be produced from our assembly file. Let me build this, prove it to you. F11, Control-Alt-D, F11, and hey, look at that, call underscore calculate next power. Right? That's kind of cool, isn't it? In fact, it's so externally visible, I can go Control-L, Control-V to get extern C void, but now I'm going to say calculate next power from C++, and just for tickles, we can call it from out here. Now in future videos, we'll learn this is kind of interesting because doit really messes with the registers and could set and send C++ into an interesting state. But for now, let's prove that we can do it. Control-Shift-B, build succeeded. Look at that. F11, Control-Alt-D. Look at that. We have a call to calculate next power, which is generated from our assembly code. We also have a call to doit, which is generated from our assembly code. F11 into that, and you can see we mess around and change the state of the registers and that sort of thing. Anyway, I think in this case where calculate next power is only needed inside of our assembly program, there's no reason that C++ needs to be able to call it. I'm going to go in here and turn it back into a label, make it internally visible but not externally linkable, and it'll operate just the same, but now it's not embedded inside of my procedure. That felt kind of weird. Control-Shift-B, and oh, look at this. What's this error here? It's coming from C++. It's saying mainer.obj. I'm trying to make mainer.obj from this mainer.cpp, and I have no idea what calculate next power is. All right, what is it? What is that? I have no idea. Well, why can't it find it? Because it's no longer an externally visible name. All right, so I hope that makes sense. Before I end this video, let me bring up my Windows Explorer here. I just want to actually, you see all these files here that Visual Studio produces when we build. I'm going to go here and say build, clean those out, and they're gone. I'm going to delete these as well. It's just frustrating. And then watch, I'm going to hit Control-Shift-B here and then bring this window back up real fast. So watch, Control-Shift-B, pop, boom, they're back. What files do we have? We have a mainer.obj that's trying to link to our other obj file. Where is the obj file produced by our assembly? Well, it actually ends up out here, myassembly.obj. But anyway, if we get rid of this reference to calculate next power and get rid of that as well, and Control-Shift-B, we're back to where we started. And these IntelliSense warnings are lame. I right-click there and get rid of show IntelliSense errors. Okay, so that's the difference between a label and a procedure. Other than that, they're the same. They're just addresses that we can call and return from and that sort of thing. So there you go.